Okay, team, we're going to get back into it again. Grab a seat. I know you've been chatting away up the back there. Come on, bloody Kiwis. Okay, we're going to carry on with this session. We have Zhai Hu is going to talk about conservation patterns in North China. That's all you.
Okay, thank you. Hello, everyone. I'm very honored to be here to share my work with you. I come from the Institute of Geographic Sciences and Natural Resource Research, Chinese Academic of Sciences, and my title is the conservation patterns of grassland ecosystem based on the forest livestock balance in North China. Actually, I have changed my title because I think this one can better reflect the direction of my research. So I apologize for any inconvenience it may bring. This is the outline of my presentation. It contains 6 parts. Here we come to the background sections. As we all know, grassland provides a wide range of materials and non-material benefits for human beings, such as the water regulation, food supply, or the carbon sequestrations. However, a large proportion of grassland area globally have been degraded in different degrees due to the human activities and climate change. Overgrazing is considered a major driver of grassland degradation in China. The grassland degradation is associated with a series of issues such as soil erosions, loss of biodiversities, and the decline of productivities. Therefore, Chinese government has launched a series of projections for grassland conservation and restoration since 2000. Many existing studies show that this project has had great positive effects on the grassland vegetations. However, the inappropriate of the measures may exert negative effects on grassland. Just as this picture shows, the planting of pine trees in the in the grassland on the Inner Mongolia may destroy the grassland vegetation and worsen the water shortage there. So it is necessary to determine a special patterns of grassland conservation and restoration for policy formulation. Forage livestock balance is a balance between the forage production and livestock consumption. It is essential for the sustainable utilization and management of grassland. And as a core part of calculating the livestock carrying capacity, forage production should be accurately estimated, and model formulation. And the field survey or the model simulation are two widely used methods, and the model simulation methods based on the remote sensing approaches is widely used because it is more appropriate for the large-scale investment. So the aim of our research is to address the two scientific questions: how does the grassland and its productivities and livestock carrying pressure change over space and time, and how to meet twin goals of grassland ecological conservation and economic development. So I will next introduce the methods. The study area of our research includes Inner Mongolia, Xinjiang, Tibet, Qinghai, and Gansu, and 5 provinces in North China. And we classified the grassland into 6 types, including temperate steppe, temperate meadow, temperate desert, alpine steppe, alpine meadow, and alpine desert. The time series of our research is 2000 to 2015. And then we estimated the grassland change based on the land use transfer matrix using the land use and land cover change images. And then we developed a remote sensing classification system for grassland degradation based on the vegetation change. And we classified the grassland change into six levels, including slight, moderate to severe degradation, and slight, moderate, obvious restoration. Then we used the MPP data to estimate the forage yard of grassland based on the ratio of above ground to underground biomass, combined with the spatial distribution of grassland types and the survey data. Here is the calculation formula, and for detailed information, you can refer to our paper published online. And then we calculated the forage livestock balance using the livestock carrying pressure index. It was estimated as a ratio of actual livestock carrying capacity to the theoretical livestock carrying capacity. And the former one is calculated based on the statistic data from the government. And the later one is calculated based on the actual forage supply. And when the index equal to 1, it refers to the forage livestock balance. And when it's process 1, refers to the grassland overloaded. When it's below 1, refers to the livestock carrying potential. And then we calculated the index under the 3 scenarios. The first one is supposing there is no supplementary feeding. And the second is the actual supplementary feedings in cold seasons. And the third is supposing there is 4 supplementary feedings in cold seasons. And this picture shows the input parameters during our calculation. Here I will show the results. We found that the grassland in North China showed a net decrease over the past 15 years. And the vegetation coverage of grassland showed an overall increasing trend. Among these, the degraded grassland was many in a state of slight degradation, and for the restored grassland was many in a state of slight restoration. And as for the forage supply, we calculated the annual forage supply for the past 15 years and found that Xinjiang has the lowest forage supply and Qinghai has the highest forage supply. And the forage supply has a trend of increasing. However, as you can see in the picture, the grassland in the Tian Shan mountain areas and the Lhasa River areas should a decreasing trend of forage supply. As for the livestock carrying capacity, the special patterns show that the low values was observed on the central Tibetan Plateau and in western Inner Mongolia, both dominated by alpine desert grassland. And as for the actual livestock carrying capacity of grassland, it shows a increasing trend. And the livestock carrying pressure on the 3 scenarios shows that the first scenario with no supplementary feeding has the highest livestock carrying pressure, especially in especially in the surrounding areas of Tamin Basin and the western Inner Mongolia. As for the scenario 2, with the actual supplementing fading, the pressure in the central and western Inner Mongolia was significantly released. And as for the third scenario, with the full sedimentary fading, it shows that most of the grassland in North China should relatively lower pressure. And while this place with extremely overloaded status still has high livestock carrying pressure. Then we conducted an overlay analysis of grassland change, grassland degradation, and livestock forage balance in different scenarios, and identified the special patterns of grassland conservation and restoration. And then we proposed different strategies according to these patterns. Specifically, for the nature reserves, key ecologic function areas, and Apple Desert, strict natural grassland protection, such as the exhibition of grazing, should be promoted. And for the degraded grassland in pastoral areas, rest grazing and grassland restoration is suggested. And for degraded or unchanged grassland with surplus or balanced livestock carrying states, rotation grazing and grassland improvement measures are advocated. And as for the degraded and overloaded grassland in farming or farming pastoral areas, high efficiency grassland animal husbandry and improving supplementary feeding is necessary. In conclusion, the total grassland area in North China showed a decreasing trend, and the forage supply of grassland and livestock carrying pressure both increased continuously over the past 15 years. And the supplementary feeding can elevate the livestock carrying pressure of grassland in central and eastern Inner Mongolia. But this effect was not apparent in other regions because of their low rate of supplementary feeding. Assuming full supplementary feeding in the cold season, the livestock carrying pressure index can be substantially reduced by about a half. And finally, we proposed various strategies to balance grassland conservation and animal husbandry production in different regions. However, there are still some limitations and uncertainties in our studies. For instance, when we calculating the livestock carrying pressure index, we did not consider the consumption of wild herbivores or consider the trade of the foraging. What's more, the assessment of grassland degradation based on the coverage change cannot detect the formulation of toxic weeds or the black soil beach. In spite of this, our studies still provide a scientific basis for the sustainable management and the utilization of grassland in China. That's all my presentation. Thanks for attention.
Okay, thank you very much for that. Unfortunately, we do not have enough time for questions, although it does raise a lot of questions about some of the integrated managements that might be applied to restore grasslands. Thank you very much for that. And now our final speaker is Anya. And we're going to talk about Colombia this time. So we've been virtually all around the world so far in this session. Thank you.
Yeah, thank you very much. My name is Anya. I am doing my PhD at CIAT, the Center for International Tropical Agriculture in Cali, Colombia, and together with the University of Hohenheim in Germany. And I form part of the Tropical Forages program at CIAT, and within that program, the socioeconomic team. So we heard a lot of talks about animal behavior in this session, but I am focusing on human behavior. And yeah, I'm talking about the cattle value chain in the Colombian Amazon. So what is the problem? The cattle sector plays a very important role for the local economy and food security in the Amazon region. However, it is linked with severe environmental damages. It's one of the main causes for deforestation in that region. And it's also linked with other environmental impacts such as land degradation, greenhouse gas emissions, biodiversity loss, and many more. In addition to the environmental sustainability concerns, also productivity levels are quite low. So this is why sustainable intensification has been on the national policy agenda for quite some years now. It's been included in several national development plans, has been included in the university curricula, etc., and several projects have been implemented to promote sustainable intensification, yet with limited success and adoption rates of improved practices, sustainable practices such as using improved pastures, integrating more trees and legumes, etc., remains at a very low level. So this is where my PhD research comes in. My objective is to improve the understanding of the adoption barriers and what drives farmers to take certain decisions or to adopt or not adopt certain practices. What are the gaps? Well, at the moment it's widespread knowledge that innovation diffusion is not a linear but a very complex process. However, in the cattle context, and particularly in the Amazon context, very little is known about collaboration patterns, information exchange patterns, learning patterns, which are important mechanisms for innovation diffusion. There's also very little known about the interconnections of different types of actors, so not only farmers between farmers, but also with other actors that are important for technology adoption. And also, what are the preferences of the farmers, not with regards to whole technology packages, but instead individual technologies. And then lastly, oftentimes farmers in many studies are considered as one group of farmers, but in fact they are very heterogeneous, and this heterogeneity is also only marginally considered. So this is my overall doctoral methodological approach. I did some qualitative research last year, and this is what I'm focusing on today. Right now I'm doing a social network analysis, and then I'm also doing a discrete choice experiment to assess farmer preferences and willingness to invest. And together with a master's student, I'm also doing a profitability analysis, because also for that there's almost no data available for that region at the moment. So first, some background. Where are we? So we have Colombia here, and I'm focusing on one department only, which is called Caquetá, and is located in the Amazon natural region. It's the third largest department, but has only 1% of the population. And what is important here is that we have the Andes running across here, more or less. So it's the Andes form the border with the neighboring department to the west. Climate, we are in the tropics, so average temperature is 26 degrees. Rainfall is very high, so average rainfall is 3,700, but in some regions it exceeds 4,500, which is a major challenge for the farmers in that region. Deforestation is one of the departments with the highest deforestation rate. It's the department with the highest growth rate of deforestation at that moment, and only in 2021, 40,000 hectares approximately were deforested.